My name is Jackson. My registration number is UR15CA059. Today I'm going to explain about my UNIX8 experiment, which is process creation. So this experiment is in this experiment we have three parts. So because where we have to create a parent process and child process. So for the first part is to that is a program to create the following process hierarchy, which is one parent, one child. So for that for that the first part coding is this, where we have the required header files and we have integer variables declared, which is seconds, minute, and hour, where we'll print the parent process and we'll get the process ID by using this system call. After that, we'll ask the user to enter the seconds. Then the second is scanned here. After that, we'll create the child process for it using fork, and if uh, PID is equal to 0, then the child process is created and parent ID is also printed there. After that, the R of second, the R is calculated, minutes are calculated, and the seconds are calculated, and we'll then we'll print the R, minute, and seconds in the format R colon minute and colon seconds. Else the process goes to sleep. Then this is the program for the first one. So we'll run it. So, so this is the output for the first one, where we'll enter the seconds like 800 seconds. So for 800 seconds it's 13 minutes and 20 seconds. So this program is running properly. Then we'll go to the next program where we have to create a C++ program for the hierarchy, where we have one parent and two childs. So this is the uh, so this is the program where we're giving the required header files, main methods, and the variables, character variables, string one, and integer variables as int and j is equal to 0, where we'll assign the parent process and enter the string, where the string length is calculated, and we'll assign the child process using for, and the child process is printed. Child process ID is printed and parent process ID is also printed, where we'll use the for loop and we'll reverse the string and we'll print it. After that, we have one more child for that same parent. So we'll use the fork and we'll assign is equal to 0, and if the child process is also printed and the parent process is also printed, and by using the for loop, the uh, string string is string count is incremented and decremented, and if the comparison of string 1 and string 2 is equals to 0, then it's a palindrome. Else it's not a palindrome. Else we'll assign the process to go to sleep. So this is the process. uh, Second experiment. Now after executing it, we'll get a output like this here, which is we'll enter the string as Malayalam, where the string length is calculated. After that, the string reverse is also Malayalam, and after that we can see that it is a palindrome string. So this is the output for that question. After that, we'll go to the second question, third part, which is where we have to show the hierarchy as one one parent, two child, and that two child have three childs. So for that, we'll use the required header file. After that, we'll assign the integer as n. After that, we'll print the process ID and enter an integer. After that, the parent ID is child ID is child process ID is also calculated and process B is created, and we'll print the both parent ID and child ID. So after that, for process B we'll calculate the factorial part. So this is the for the factorial part. So after that, we have process D, where we'll also print parent process ID and child process ID, and we'll assign some integer variables where a is equals to n and x is equal to a, where b is equal to 0 and c is equal to 1, and d. After in this process, we'll calculate the Fibonacci series, and after that, we'll go to the process C created, where the same process is going on, and this in this process we'll calculate the Armstrong number, if the given number is Armstrong number or not. So after that, we'll go to the process E created, where we'll see that if the given number is a prime number or it's not a prime number. After that, process F is created, where we'll do the similar things what we did it previously, and after that, we'll see the reverse of the string. So so this was the third program. So for output of this third program is given here. So we have to do a integer as 12. So we can see that process A is created. Process A calculates the integer, enters the integer. Then after the process B created is by factorial is calculated, and Fibonacci series is calculated by D and C as the Armstrong number, and F as the reverse of the string, and E as the it's a prime number or it's not a prime number. So the program is working properly. Thank you for watching this video.